Okay, so what I like to do is new file, and I've just set it up to come this way, but you might have to configure this, and then we can always ask on Slack and we can help you out. We just save this on the desktop maybe. I can't find the desktop. Okay, save it in documents. Okay, so what we'll do is just start putting things down. The main building block, unlike so MATLAB, is the main building block is a matrix. In case of Python, it's a list. So a list is basically heterogeneous. You can put whatever you want in the list, and basically, if you want to see what it looks like, so in MATLAB, the good thing is that if you just run this code without a semicolon, it actually prints whatever you wrote there, but not for Python. You have to put a print statement. So if you say print list, it should print the whole list. Okay, and then if you do print list 0, that's the first element. So remember that unlike MATLAB, which starts from 1, Python starts from 0. Same for C. Right? You could add an element list dot print. If I want to add, let's say test, and then if I want to say print list, you say it's 1 hello, then this is just printing the 1, and then the elements are 1 hello list. Okay, if you want to print the last element, you can also do this -1. So test was the last one, and that's what it gives. So this is getting clunky, so I'm just going to comment this out. Okay. So the shortcut is control \. Okay. Okay, so now let's just go to some conditionals. So let's say that I have C equals 10, and then the way you write a conditional if else is if, let's say, if C is greater than 0 and C is less than 5, print C is between 0 and 5. Okay, and then note that I put this colon, and then there's a tab space. If you don't have this, then it will actually give you an error. So C is great. Okay, so clearly, if this in this case the conditional is clearly it's greater than 5. So if you run this, it does say C greater than 5. But then if you want to print C, this called F literal, which you can use. So print F equals. Okay, so this is just telling that if you want to print C, you put an F literal, and then you put it in the curly brackets, and then it should print the value of C. So if you run this, so it says C equals 10. Okay, so this is a useful trick if you want to write the value. Okay, so then let's do a while loop. Okay, so I want to print numbers from 0 to 4. So print I, and then remember that I needs to be increased, right? And then I want to, yeah, that's it. So let's print. So you have 0, 1, 2, 3, 4. So here's the interesting thing. When you say 0 to 5, remember that it prints from 0 all the way to 1 less than this number 5. So 0 to 4. Okay, then functions. You can define function anywhere you want. Let's say a function. Use the colon to say that that's the end of the line, and then when you press enter, it typically goes in the next line with the tab from function. So this is just definition of function. If you want to call the function, you just call it the way you would call in any other programming language. So call my function. So here it says hello from function. So it calls that. You could also write, it could also accept input arguments. Let's just do a simple addition, a and b. So remember that a and b are dummy variables, or they don't have global, they're local variables. So a and b you can define again anywhere in the code, won't affect this. So all you need to do is you need to say sum equals a plus b, and then of course you want to return sum. Okay, so if you want to do add 3, 5, now by default this will not print it out. So what I need to do is I need to save this in C and then print C. Or let me just choose something else, D, because I use C. Okay, so if you run this, so you get 9, which is the answer. Okay, now it turns out that you don't have to write some simple functions. Always search if there's something available. It turns out that by default, Python doesn't have an add. I don't think so. There is a package called NumPy. Okay, so what is NumPy? You can just search for it. Okay, so there is a whole numerical Python package which is very powerful. It has a lot of functions, and in this case you need to basically call that, import that package, and then use the tools in the package. So in this case I'm importing NumPy as NP. So this is basically what they call object NP. Think of that as an object. In that object there would be different functions like add. So if you want to access add, then you just say np.add. So the same thing can be done this way. D2 equals np.add 4, 5, print D2. And then if this is right, it should print 9 twice. So it takes a while because it's loading that package, but you can see 9 2 times. Now what will happen is if you are using Visual Studio the first time, it'll basically show up, it'll underline NumPy saying that this package is not available. So in this case, that is, if you're using it first time, this will not be installed for you. You need to go to terminal here, and here you'll say pip install NumPy. Okay, when you say this, it'll basically install NumPy. Of course, you need an internet connection to this. So here it is telling me that I already have NumPy, so it's not a problem. But if you don't have NumPy, you need to update it. Okay, so remember that. Okay, so that's that. Let's start using NumPy. I think it's one of the most useful package, at least for us in this course. And I'll just show you how NumPy is used in this course. So what we'll be doing, as you'll see in this course, is that we have to deal with matrices. A good thing about MATLAB is everything is a matrix, so it's very easy to work with that because it just assumes everything is matrix. But here we'll be using NumPy extensively because it gives you access to matrices. So when you import NumPy as NP, you're ready to use the package or the functions inside the package. So if you want to define a matrix, let's say in MATLAB, let's say you define as 2, let's say a equals 2, 4, 5, minus 6. Okay, this is how you would define a matrix in MATLAB, right? The first row is 2 and 4, and then the semicolon means that that's the end of the line, and then 5 minus 6 would be row 2. Now, if you want to define the same thing in Python, I really don't like this. It's a lot of work to get to the point where you define the matrix. So you need to basically define it as an array. You can also define it as a matrix. So np.matrix is also fine. Okay, then you need to open a round bracket. And here you need to have a square bracket. And within that, you will define the first line 2, 4, and then 5 minus 6. Just seems like a lot of work to write 2 by 2 cross 2 matrix. Okay, so that's A. If you want to anytime figure out what A looks like, you just say print A. and then it shows A. Now here's the thing. What I find when I do these things, we'll be using matrices extensively. In fact, we'll be dealing with 3x3 and 4x4 matrices extensively in this course. So you want to basically be very good at matrices. Now, the thing which really helps me all the time in this course is that, and especially when I'm debugging, is to know what A is. Sometimes you don't know what it is, so you could just do print type A. Okay, and the other thing which is important is np.shape A. So it tells you how big, what the size of A is. So if you run this, so that's an ND array. So it's a NumPy n-dimensional array, and this is saying it's a 2x2 matrix. Okay, very often you will see that if you try to take ND array and add it with something which is a list, you'll get an error, and then you will have no clue what's going on. The best way to do it is to check the type. Okay, so that's important. Another thing is when you try to multiply two matrices, if the order is not right, you cannot multiply them. So it's always nice to remember these type and np.shape. Okay, the other one is len, which we'll talk about in just a bit. Okay, so we have A. Let's define a B because we are trying to do a matrix times a vector. Again, same thing. Open the bracket. Here it's going to be just two elements, so I'll just write it as 1, 2. Print P. Print. Let's not do type, but let's do np.shape. Okay, so here's the thing. If this is a 1, 2, that was the elements 1 and 2. But then, you know what, let me use something else because I think it's going to confuse with this. It's 7 and 10. That way it's not, it doesn't look like a size of the matrix. Okay, 7, 2. This is kind of weird. You see, it's saying it's a 2, comma. So it's basically a NP array of this size, and that's going to, I wish it was 2x1. You can actually reshape that by going 2x1. This has consequences because now when you try to multiply, like if you want to do A times B, if you run this, I did not do print. Sorry about that. So print. So you see what you get. If you do A times B, you get 14, 40, 35, minus 60. You expected a 2x2 times a 2x1 would give you a 2x1, but it gives you 2x2. It's because it does element-wise multiplication. So the way to fix this is to actually write it as A dot B. Yeah, so it gives you the right answer. Hopefully that's the right answer. So it does the actual multiplication which we are used to, A times B. Okay, so this dot is basically a function inside NumPy, and you're using that function to do the dot product. This is a nice way of calling this. Instead of saying function name and putting the argument inside the bracket, here's the way to call this. Okay, now there are other things you can do if you want to take the transpose of A. That's the transpose. So 2, 5. Let's see. I'm going to print A so we can compare. So 2, 4, 5 minus 6. We take the transpose. It's this. There's another way. I think it's print A dot T. I think this should also work. Yes, that also works. So here's the other thing, which is there are multiple ways of doing the same thing. So don't get it's good and bad. It's good, I guess, because you have a shorter way of writing it, but it's bad because now when you see code like this, and you don't know that's the transpose, you're just going to be like, what's going on there? So you'll have to do a print maybe to figure out what's going on. There is we'll also compute the inverse np.linalg dot inverse A. So this is basically in the NumPy there is a linear algebra function. I think it's package would be the wrong name. It's basically a function in NumPy and that function has a function which basically does the inverse. So function instead of function. So if you can see the output, so how do you check that? Well, you could. How do you check the inverse is right? You just multiply it with A and see if it gives the identity matrix, right? So let's do that. Print. I'm going to take A, and I'm going to use np.matmul. So this basically multiplies as a matrix with another matrix. So I'll take A and multiply A inverse. And then if the calculation is right, this should give me the identity, right? So it's 1, 0, 0. There are also some definitions which, if you want to create the identity, you don't have to write create NP array and then create the identity. There is like functions available for that. So if you want to create a 2 by 2, or let's say 4 by 4 identity, then that would do it. So 4 cross 4 identity matrix. There's also a np.zeros, which initializes. It's very useful when you want to initialize something. Okay, so the best way you can, I mean, long time back, I used to just go to Google and search for it, but now you can just say whatever you want. You put in ChatGPT, it tells you. You could use this. Probably there are 3 or 4 ways of doing the same thing, at least the way Python is set up. So it'll give you them. Okay, now let's go to plot. So this is important, as I said, because we'll be dealing with matrices extensively. Plotting is obviously important because we want to take whatever we do in this class and basically make graphs to understand what's going on. So that's another useful skill to have. So let's just do a simple plot. This will not work. Let's do file, new file, Python. Save it. Okay, so for plot, we will use a package called matplotlib. We inside matplotlib, there is another function called pyplot, which is the one we'll be using. So we'll import not just matplotlib, but matplotlib.pyplot as PLT. Okay, so now we are ready to use tools within. So each time we don't have to write this whole these 2 words, we can just write as PLT, as you see. This makes our life easy. So let's create. Let's just go to plot sine of x. Okay, so just see how that goes. I need to do linspace, so that is available in NumPy. And then linspace basically populates the interval from whatever start to end, let's say pi, with, I don't know, 100 points. Now you can see that it put a underscore here. That means pi is not defined. So pi is not defined in Python by default. So what you can do is you can use the pi as it is defined in NumPy, and that is fine. Okay, so x is defined there. What we'll do is we'll call y equals sine of x. Okay, now again, there's a problem. Sine of x is not defined. So it will give you an error. So what you can do is you can use the sign available in NumPy. If you want to use sign as sign, what I try to do, just sometimes you have lots of signs and writing np.sign is too much work. You could just do this. Define sign of x. And then you can say return np.sign of x. So now this will work just as fine. It won't give an error because it's going to use np, but here I've basically escaped writing that. Sometimes you might want to do, just to make your life even simple, you could just write it like this. It's up to you. Okay, so y equals sine of x. All I need to do is say plot x comma y. Okay, now this is a problem. There's no plot available in Python, so you need to use the package plt.plot. And now this by itself, I can run this. It'll do nothing. It doesn't show anything. You can see, because you need to use plt.show. Okay, so plt.show. Okay, so it's plotted sine, and then you can do things like, let's do plt.x label x, plt.y label y. And then if you want plt dot plot of sine of x. Okay, so on this, okay, so what happens is opens, and then you need to close it to proceed. If you want it to close automatically, you can actually use this block of code, plt dot show lock equals false, and then you time it. So say you say plt dot pause, so it waits for whatever number of seconds you specify, let's say 4 seconds, and then say plt dot close. Okay, so 4 seconds, it'll close. Okay, so that's the other skill. Now, the third thing, which will be very important, is robotics is all about visualization. So when you are trying to debug things, if you make an animation of whatever you're doing, it's much easier to see what the problem is. Now, if you're programming a real robot, animation is done for you, like the robot is moving. But how do you do it in computer simulation? So turns out that you can actually do simple animations using what is available in Python. So let me just show you uh, so a simple thing, which is you have a sine of x. Let's put a red blob or green blob and move it around the sine function. So you file. So I'm just going to copy paste the old code because I'll just modify this slightly. And then let's call that animation dot y. Okay, so we have the sine, and my intention is to show maybe a green marker which goes along the sine, takes a ride along the sine. So how do you do that? Well, let's just plot a green marker first. Just do it one at a time. So plt dot plot. So I'm going to do the same plot, x comma y, but instead of using uh, the blue line you saw, I'll just use a marker. So for that, we need to give it a color. Marker, say O, and then marker size. Okay, so how do I get this? Well, one way of figuring out what this syntax looks like is, of course, you could put it in ChatGPT, but you could also go and say matplotlib plot, and then this is the documentation, and it actually tells you how to go about this. So plot x, y, and then there are a bunch of, these are the bunch of options. You go down, it should probably tell you the options. It actually also gives you examples. So if you do this GO minus, it means that it'll be a green line with a O marker of which looks like a 0 or a O, and it'll be a dashed line. So color, that's what I used. Then line width, I didn't use that. Marker, that's one I used. You can click on that to get more information. You can put marker, color, and size. So that's how you get information about how to use them. But you could also say, I want to do something like this in ChatGPT. It'll also help you out. Okay, so let's just look what this looks like. Save this and run. Okay, so that's what we expected. Now what we want to do is we want to take a green blob and just move it around the sine. So what we'll do here is we'll write a for loop in range 0 to, we want to cycle through the whole x. So we'll say len. So what this len x does is gives you the length of x. So I is a counter which goes from 0 all the way to whatever the dimension or whatever the number of elements in x are. So there are 100 elements. So ln x would be 100. So it'll go from 0 to, in this case, 99. Okay, so we just take this, put there, And now remember, I want to do it one point at a time. So x, I. Okay, and let's try running this, see what happens. Okay, so that was very fast. You didn't even see it plotting it. But what we could do is we could put a pause. ELT.pause 0.0. So this is a pause in seconds. So it waits for 20 milliseconds. So it gives the impression that it's actually plotting. So it goes now. So it's like a flip book, right? If you have these pictures and if you put them together, then you get animation. Now that's not ideal. We don't want that green blot to we want it to disappear. Like you just want one dot to be showing up. So what you could do is you could actually take this object. I'll define it as tmp, and then I'm going to just say after pause, I'll say tmp.remove. So what it does, it plots, waits for 2 milliseconds to show you, and then it erases off, then replots, and so on. So if you run this, now it looks like it's sliding, right? Now you could adjust the speed by changing the pause. Another way to change the speed is to change the number of points. So instead of 100, you could put 150. It'll go slower. So there's something which you need to do depending on your system. Some computers, this will be very fast. If you have a newer system, it'll be much faster. If older system, will be much slower, because that pause depends. It's really a computer specific thing. Even though it's 2 milliseconds, it just becomes a computer specific thing. You can try test it out, even though it shouldn't be. It should be computer independent. Okay, so last thing we'll do, and I'll let you go, is and this is where we really want to get to, is we can do some really sort of say fancier animations using Python. There are circles and rectangles and lines and so on, which are readily available in Python, which you could use. So you don't have to write. If you want to draw a rectangle, you don't really need to do much work drawing the four sides of a rectangle and filling it up. There's something called patch, which you can use. So I'm just going to do one last program, and then we'll stop. And that will be the introduction to conclude the introduction to Python. So new file. Okay, so what I'm going to do is, just to show you how it works, is I'm just going to draw a rectangle, and then I'm just going to show a yellow blob going up and down, sort of like the sun going up and down, setting and sunrise and sunset. That's what my goal is. And let's see how to do that. So I'll do it interactively. We have for time. Okay. So we will be using two packages. We will use NumPy, and then we'll use matplotlib as PLT. So we'll call this animation fancy. Okay, so fig plt dot figure. I'm just setting up a few things. Ax equals fig dot add subplot 111. Okay, and then plt dot show, and then all my code has to sit in between this. Okay, so let's start doing this. So first, I'll show you how to just draw like a rectangle. So there's something called plt dot rectangle. Okay, and then it's best to see what it does. So we just type plot matplotlib. Okay, so you go here. This is matplotlib rectangle. It has a few things you need to specify: x, y, width, and height. So x, y is the bottom left corner, and then height and width. I think that's enough for us. You can actually also specify the color that actually appears in the extra arguments. So we'll set it up at 0, 0, and then we'll specify this to be, I don't know, 2 units, and then that height to be 1 unit. So how do you do that in Visual Studio Code? Is we'll specify the left corner, then we specify the length, we specify the height, and then let's say a color equals brown. Okay, now this by itself, if you run this, nothing, it will not create anything. It's just going to be a, oh, there's an error. ELT. Oh, this should be pie plot. Okay, so it did nothing, right? That's because you need to add the patch. So there's a ax.add. So ax is your figure. You need to say add patch, and that's just how they designed it. That's how the thing works. So add patch, and then you need to give a name for the patch. So let's call this rectangle, RECT. Okay, so if you do this now, it should show. Okay, so one unit doesn't look right. It's because the plot is by default is set to be 1, 1. What we can do is we can specify the dimension to be whatever we want it to be. So what we'll do is we'll use plt.xlim. Okay, this specifying the limits, x limits 0, 2. So 0 and 2 along the x-axis, and then the y limits, just make it square. So y lim 0, 2. Okay, it's much better. Okay, now let's draw a circle. Okay, so again, you can go and check the syntax. The syntax for a circle is you give the xy coordinates of the center in this case. So if you remember, middle of this would be 1, x will be 1, 1. Okay, so that would be the just middle of the screen, and let's say that the radius is 0.25, and then color equals yellow. Okay, and then we say run. Okay, so I did not do add patch. Just to add. Okay, so that doesn't look right, right? The axis is stretch. So what you could do is you could actually have the axis equal. So let's go here and then say the syntax is plt dot. So this is a syntax which was really hard for me to get, but I think I just Google searched it when I wrote this code. Okay. So now if you run this, it shows perfect. Okay, now what I'm going to do is I'm going to set this up here, and then we can go down and up. So let's set it up at 1. X equals 1, y equals 1.5, right? 1, 1.5. So it's going to go up. But then okay, just rerun this. What I'm going to try to do is get this to move from here, sink inside, and go, and then maybe later on get it up. So I wanted to go from 1.5 to 0.5, so it'd be perfectly buried inside the background. So let's create a variable y, and this will be np.linspace. So it's going to give the trajectory for the sun. So that will be going from 1.5 to 0.5, and we'll specify 10 points. Otherwise, it'll be 2. If you specify 100, it's going to take a lot of time. And what we'll do here is we'll run a for loop, because that's how we did the blob in the past. So for I in range 0 to len y. What we'll do is we need to take this code and run it in a loop. But we also need to add the patch. And then we should not forget to put the pause. So plt.pause 0.1. Okay, so it did not move. That's because I did not really make it do anything. So we just go and change this to I. That's weird. Uh, the resizing was weird. Maybe I know how to do this. So maybe what we want to do is move this up here. Okay, so that fixed that, but we don't want this to happen, right? We want to delete the patch. So what we'll do is we will just say remove. So just like we did the blob. So here we just after the pause, we'll put patch, no, the circ dot remove. So it deletes the circle and then plots it again. Okay, so it went down. We wanted to make it to go up again. So what we'll do is we'll do the reverse of this. Okay, so y2 would be the reverse. So 0.5 to 1.5, and then we'll concatenate these strings np dot concatenate y1 y2. Okay, so it's doing that, but the problem is you can see that you don't want the yellow blob to be showing outside. It should be hidden inside the brown box, right? So what we'll do is this is something which actually is new to this. If you see the order in which this is specified, the rectangle is specified first, and then the circle, this should have worked as expected. It actually did work in the older Python version, and the new Python version, it actually doesn't work. You need to do something different. You need to actually put the Z order. And this is something which I just learned from, it did not work for me today. And I just put it in the chat GPT and it told me that I need to specify Z order. That's a new thing. So Z order 2. So it's the order at which you show the overlay. So here we run this. It did not work. I think I might have to choose a higher order. Let's try 3. Nope.